Hi everyone. So today I'm going to be going through six kind of classic paper one questions ready for you guys on Thursday. So we're going to be going through six foundation level questions today. So the first question is this one. So work out an estimate for 5.7 multiplied by 8.2 divided by 0.26. So you'll feel free to pause the video at any point if you want to have a go at the questions, but I'm just going to be going kind of straight into it. So sometimes and this is kind of what I'm going to go through with each of the questions as well. Sometimes there's a particular word or the question is kind of written in a particular way, not to necessarily throw you off, but it could definitely throw you off if you don't know kind of what that word is essentially asking for. So as soon as you see that word estimate, take a deep breath, take a sigh of relief, because it means that you don't have to literally work out that calculation. In fact, if you do, you're not going to get any marks. You don't want to start literally doing 5.7 multiplied by 8.2, etc. Because of that word estimate, you're going to round everything to much nicer numbers. Me personally, I recommend rounding all of the numbers to one significant figure, making it as easy for yourself as possible. So 5.7, I'm going to round that up to 6. 8.2, I'm going to round that down to 8. And then 0.26, I'm going to round that to 0.3. So now everything is one significant figure, making it much, much easier to work with. So I'm going to kind of rewrite this question a little bit because dividing something by 0.3, some people don't really like working with decimals. So I'm going to kind of take the decimal out of this and just put it into a fraction because people like to work with fractions more so than they do decimals. So the 6.8, I can kind of sort that out straight away. That's going to be 48. So then we've got to do 48 divided by 0.3, but I'm going to change the 0.3 and instead I'm going to divide it by 3/10. Just because you might feel a lot more comfortable dividing with fractions than you might necessarily be with dividing with decimals. So when you're dividing with a fraction, remember keep, kiss, flip. So you keep the 48. The divide becomes a times, that's the little kiss. And then the 3/10 gets flipped. So that becomes 10 over 3. And then you just multiply as normal. So 48 multiplied by 10 is 480. Divide that by 3. You can then just do kind of bus stop method. I'll do that over here. So 480 divided by 3 is 160. And then that would be your answer. And then in the mark scheme, just to kind of let you know essentially what the examiner is going to look for, because of that word estimate, everybody is going to round their numbers to something slightly different. Not everybody is going to round them to one significant figure. That's just what I do to make it as easy for myself as I can. But other people might have chose to round them to something else. So in the mark scheme, it will say as long as your answer is in between 160 and 200, then they'll give you the mark. So as soon as you see any sort of question in the exam that has the word estimate, in the mark scheme, there'll be some sort of boundary. So you don't have to be spot on perfect, but as long as you're within the right sort of area, you will then get full marks. And of course, 160 was bang on there in that boundary. So perfect, full 3 marks there. So then the second question that I want to go through is something like this. Again, a classic for paper one. So this question is there are 200 counters in a bag. 38 counters are red, 52 counters are blue. The rest of the counters are yellow or green. There are the same number of yellow counters as green counters. What percentage of the counters in the bag are yellow? So it's that last bit that's a classic. So I'm going to work out as a fraction first. So I'm going to work out the fraction of the counters in the bag that are yellow. Then I can change that into a percentage. So we've got 38 red counters, 52. I don't know why I just did a line underneath that. The line is coming, but not yet. And then 52 blue. So that's a total of 90 counters. So 200, take away the 90 red and blue counters, leaves us with 110. And then it says that there are the same number of yellow counters as there are green counters. So if I just divide 110 by 2, I get 55. So there must be 55 yellow counters. So as a fraction, there are 55 out of 200 yellow counters. So now the kind of non-calculator skill is now converting that fraction into a percentage. Because of course, if we had a calculator, type it in, gives you the answer practically straight away. But this time, what we're going to do, because we don't have a calculator, of course, we're going to make that fraction over 100. And then once you've done that, whatever the number is on the top, that's your percentage. So I'm going to simplify this fraction just a little bit so that it's over 100 instead of 200. So to get from 200 down to 100, I've halved it, I've divided by 2. So I've got to do the same thing to the top. So half of 50 is 25, half of 5 is 2.5, so that's going to be 27.5. Don't be put off by the decimal, it still is perfectly acceptable. So the answer as a percentage is just 27.5%. And then there you go. So something like that, not necessarily in the context of counters or anything like that, but definitely like giving your answer as a percentage. Classic for paper 1. So just work out the answer as a fraction first, simplify the fraction. Well, it might not even be simplifying, just kind of change the fraction in whichever way you can to make the fraction over 100. And then whatever number you've got there on the top is then your percentage. And that's it. And that question was 4 marks. So a pretty chunky one there. So yeah, quite a hefty question. Okay, then we've got this type of question here. So Alexi is using a map. The map has a scale of 1 to 25,000. On the map, a road has a length of 6 centimetres. Work out the length in kilometres of the real road. And this is a 3-mark question. So sometimes a lot of people get put off by this sort of question because they don't know what units the scale is in. It doesn't say specifically. But if it doesn't give you any specific units on a scale, you can assume it's all in centimetres. So essentially what that scale means is that 1 centimetre on the map is 25,000 centimetres in real life. So you can always just assume the scale is going to be in centimetres. So if the scale is 1 to 25,000 centimetres, and then on the map a road has a length of 6 centimetres, that means I've got to multiply the 25,000 by 6, and then that will give me the amount of centimetres that the length of the road is in real life. So I'm going to do 6 multiplied by 25,000. So you can kind of do this in whatever way you feel comfortable doing, but I know that 6 times 25 is 150, so then I can just put the 3 zeros on the end, just like that. So I've got the answer now in centimetres, 150,000 centimetres. So now I've just got to convert that into kilometres. So I'm going to put my 150,000 down here just to make it a little bit clearer. So rather than going straight from kilometers to centimeters, I'm going to write it in meters first, then go up to kilometers or kilometers, however you say it. So there are 100 centimeters in a meter. So if I divide by 100, that's going to be 1,500 meters. Then there are 1,000 meters in a kilometer. So I've got to divide by 1,000. So 1, 2, 3. So my answer is 1.5 kilometers. And then there you go. So just remember, if the scale on a map, the units haven't been given to you, you can just assume that it's going to be in centimeters. But this idea of then converting it into kilometers, classic again for paper one. So again, something that is good to practice for that one. Okay, halfway through, we're on question number 4. So this time we've got a little bit of speed, distance, time. Again, classic for paper one, but there's something in here in particular that is there to throw you off. So we've got Liz, and Liz travels 18 miles in 20 minutes. Work out her average speed in miles per hour. And I'll say again, if you want to have a go at any of these questions, just pause the video at any time. So to work out the speed, I'm going to have to use my other pen for this one because the internet isn't letting me do it. So to work out the speed, we have to do the distance divided by the time. That's just the formula that comes in. So if you was to do 18, because that's the distance, divided by 20, that would give you the speed in miles per minute. We don't want the speed in miles per minute, we want the speed in miles per hour. So a lot of the time, the question will try to put you off because it will give you the time in minutes. So always make sure that you're working with time in hours. So, 30 minutes is half an hour, 15 minutes is a quarter of an hour, 20 minutes is a third of an hour, because you got 20, 40, 60, so that's a third of an hour. So I'm going to change that to 1/3 of an hour. There we go. So now I can do distance divided by time. Lovely. So my distance is 18. I'm going to divide that by my third of an hour. So similar to the question we've done previously, we're dividing with a fraction. So I'm going to do keep, kiss, flip. So I keep the 18. The divide becomes a times. That's the little kiss. And then the 1/3 is going to flip over and become 3/1. But if a number is over 1, you're essentially just going to do 18 times 3, which is 54. So 54 miles per hour is your answer. So as soon as you see anything about speed, distance, time, just make sure your time is given in hours. If it's not, change it so that it is in hours. Then you can do your normal calculations from there. Okay? So let's have a look at question number 5. Here we go. Again, classic for paper one. I'm sure you've all seen these sorts of questions a million times already. So we've got write 200 as a product of its prime factors and give your answer in index form. That's the kind of key bit here. So first of all, I'm just going to get the product of prime factors. So as soon as you see those words, think factor tree. So I'm going to pop 200 at the top, and then you're just kind of breaking that number up into kind of smaller factors. So it doesn't matter which numbers you use here, we're all going to end up with the same prime factors in the end. So 200, I'm going to split that up into 100 times 2, and then 2 is prime, so I'm going to circle that. So 2 is a prime factor. But 100, not prime, so I can split that up a little bit more. And I'm going to split that up into 10 times 10. 10 is not prime, so I can split those up even further. And I'm going to split them up into 5 times 2. And then 5 and 2 are all prime. So it wouldn't have mattered what factors you used, we're going to end up with the same prime factors in the end. So then product just means times. So if you was to write 2 times 2 times 2 times 5 times 5, that would be fine for the product of prime factors. And that's it. But this question has specifically asked you to give your answer in index form. So if you left it like that, you would only get 2 out of the 3 marks. You must give your answer in index form to give you that final answer mark. So index form just means that you're going to have 2 to the power of something and 5 to the power of something. So because we've got 3 2's there, 2 times 2 times 2, that's going to be 2 to the power of 3. And that's being multiplied by 5 to the power of 2, because we've got 2 lots of 5 there. So that is the answer that they're looking for here. If it doesn't specifically say to give your answer in index form, then you don't have to. You can if you want to, but you don't have to. It's only if they specifically ask for it, then you have to write it like that. So maybe it's worth just writing it like that all the time, and then you know that you're covered either way. And then there you go. That's writing a number as a product of its prime factors, giving your answer in index form. So then the final kind of classic non-calculator question is something like this, and this is 2 marks. So we've got work out the value of 4 to the power of negative 6 multiplied by 4 to the power of 9 divided by 4. So with this one, there's a key word. There's something in the question again that is not necessarily trying to throw you off, but it is wanting your answer to be given in a particular way. But we'll get to that in a second. So this is just your indices, your index laws question. So I'm just going to deal with what's happening on the top, then I can work with what's going on the bottom. So on the top, I've got 4 to the power of negative 6, and I'm multiplying that by 4 to the power of 9. So because my base numbers are the same, they're both powers of 4, all I have to do is add the powers together. So negative 6 add 9 is going to take me up to positive 3. So 4 to the power of 3. But then I'm still dividing by 4. But that 4, you have to remember, it's not put on there, but again, trying to throw you off, that 4 is actually to the power of 1, because it's just 4 by itself. So then now that I'm dividing the powers of 4, now I have to subtract the powers. So 3 take away 1 is 2. So my final answer is 4 to the power of 2. However, that would get you 1 out of the 2 marks, but because it says to work out the value, so sometimes it says work out the value, sometimes it might just say the word evaluate, like that, but it's still got that kind of value sort of element to it. That means that they don't want you to leave your answer as a power of something. It wants you to work out what actually is the value. So what actually is 4 to the power of 2. So 4 to the power of 2, or 4 squared, you just multiply 4 by itself and you get 16. So 16 will be the answer that they are looking for. So there you go. There are 6 questions that are classic for paper 1. So, can't guarantee that they're going to be there on Thursday, but they're fairly likely to. So hopefully you found that useful. Any questions, just pop them in the comments. And yeah, if you need me for anything else between now and then, just send me a message.